Today we're going to talk about some more stuff with pyramids and starting to put things together. We're going to start with a pretty much a review thing, and that is setting up and finding the volumes of similar solids. Nothing changes between what we did with prisms and pyramids here. Okay, the same principles still apply that we learned a couple days ago when it came to similar prisms. So again, we need to find the scale factor between the two shapes. We cube the scale factor and use that to set up and solve a proportion. So if we're going to break it down into steps, okay, step one is find the scale factor. Step two is cube it. And step three is use number two to set up a proportion. And then finally solve proportion, I guess. So that's kind of the process that we go through with this whole thing. So let's just do that here, okay? First, we need to find the scale factor. I need to know one pair of corresponding parts that I know the lengths of both sides. So here, obviously, we have our heights. Okay, we got our height here is 8 and our height here is 6. So the scale factor, large to small, is 8 to 6. But we have to reduce that for a scale factor to the lowest term, so that's 4 to 3. Okay, so the scale factor is 4 to 3, or if you prefer, 4 to 3. Either way. I cube it. So I got to do 4 cubed to 3 cubed, which is 64 to 27. Okay? A little bit bigger numbers, but that's okay. Now we use this solution to set up a proportion. So 64 over 27, the ratio of the volumes, has to be the big volume over the small volume. The big volume is known. So there's step 3. Step 4 is actually solving this. And we've got a little bit of work to do here, obviously, because we've got some pretty big numbers. But 7 times 96. Hold on, let me get that. 27 times 96 is 2,592. We divide by 64, and I get 40.5. So my volume is 40.5, and of course, context, meters cubed. So we create our context. All right, let's practice. Now I've done one. Now you do one. Find the volume of pyramid D. All right, give it a shot. The other thing we're going to do is we're going to start putting our solids together, and this gives us a chance now to practice all of our skills with finding volumes. So if I want to find the volume of the composite solid, this is the same thing we did before. We have to come up with a plan. So in order to find the volume of the whole thing, that whole house type shape, let's call it, I'm going to have to find the volume of the base, or volume of the cube, plus the volume of the pyramid. Now I need to know how to do that. Well, the volume of the cube is base area times height. The volume of the pyramid is base area, and that's by the way the height of the cube, is base area times the height of the pyramid divided by 3. Now here the height of the cube and the height of the pyramid happen to be the same, and we're going to use this for our base because it's the same base that's here. So the base areas are the same also. That makes life a little simpler. And what makes things even simpler still is that base is a square. So my base area is 36 times the height of the prism, which is 6, plus 36 times 6, again, because the height of the pyramid is the same as the height of the cube in this case, divided by 3. So, hold on. Calculator turned off on me, but we'll get it back on. 36 times 6 is 216. And then 36 times 6 divided by 3 is 72. And 216 and 72 is 288. The unit is meters squared. Okay. I'm sorry. Meters cubed. Mind wandered for a second there. Volume, not area. So 288 meters cubed, that is my volume. Pretty simple. This is a little bit trickier to see, but we have a triangular-based pyramid on top of a triangular-based prism. It's okay. My strategy is still the same. My plan is still find the area or volume, volume of the prism plus the volume of the pyramid, which is still base area times height of the prism, plus base area times the height of the pyramid, divided by 3. The base in this case, in both cases, is this triangle right here. And I know the length here is 8 and the height is 4, so this is a triangle. It's base times height divided by 2. 8 times 4 divided by 2, which is 16 feet squared. The height of the prism is 5 feet. The base area of the pyramid happens to be exactly the same, 16 feet squared. Plus the height of that pyramid is 3 feet. Times the height of the pyramid, 3 feet. And that's going to be divided by 3. Now, what's awesome here is the 3's cancel. So that makes my life a little easier. 16 times 5 is 80 feet cubed. 16 feet times feet is 16 feet squared. Or feet cubed again, excuse me. And 96 cubic feet is that volume. So it really comes down, obviously, if you can't find the area of a polygon, so you can't find the area of the base, this is a nearly impossible task. So you need to know your area formulas. You need to know your volume formulas. You need to be able to apply those on a regular basis. So memorizing these formulas is huge. And again, I've got that extra podcast out there with notes on basic area formulas if you need it. All right, one more for you. The Louvre Pyramid. It has a height of about 72 feet, and the square base has a side length of about 116 feet. So we've got a pyramid with a square base. And just draw a nice little picture here, because this would be the strategy we'd use if we were trying to solve this problem. We got a pyramid with a square base. Okay, and these are kind of going to be my dashed sides back here. These are my solid sides. Okay, in fact, to make it easy, I'm going to grab now, whoops, I want to grab this, pull that out of the way, and now I can bring this back. There we go. I didn't want it. That's fine. I'll make it work. Okay, and now we'll put our top up here. So actually, that would be seen, wouldn't it? And our height down the center here, sorry, undo that one. Oh. Try drawing again. Okay, our height down the center here to the center, that's going to be, so we've got this is 72 feet high, and the side length is 116 feet, and you need to find the volume. Okay, so use your volume formula and find the volume of this pyramid. That is your final problem for the day.